Solar energy. It powers our homes, our cars, and, our hopes for a greener planet. When we see solar panels, we think progress, right? A clean, simple solution to a really dirty problem. But the story of how they're actually made is, well, it's way more complex. And it forces us to ask some very, very difficult questions. So first, let's just be really clear about why solar is such a huge deal. This isn't some niche technology on a few rooftops anymore. It has absolutely exploded into a dominant force on the global energy stage. And the vast majority of this market, we're talking about 95%, is dominated by just one technology, crystalline silicon. So that's what we're going to be focusing on. And let's make no mistake, this is a genuine success story. Once a panel is installed, it just sits there, generating clean electricity for decades. It's a massive help in moving away from fossil fuels. But the story of what happens before a panel gets installed, well, that's where things get complicated. Because it's on that journey, from raw sand to a finished panel, that's where we find its hidden environmental and, yes, its ethical footprint. Okay, so this diagram lays out the whole process. It starts with mining silica, which is basically just super high purity sand. That gets purified into something called polysilicon, which is then formed into these massive crystals called ingots. Then those ingots are sliced into these impossibly thin wafers, and those wafers are assembled into the cells that make up the final solar panel. As you can see, every single step is incredibly high-tech and really, really resource-intensive. And at each stage of that complex process, you find these hidden costs. Manufacturing takes a massive amount of energy, and often that energy comes from carbon-heavy power grids. It creates hazardous chemical waste. Slicing those wafers means a lot of that expensive material is just lost, turned to dust. And maybe most troubling of all, there are documented risks of forced labor in the supply chain. And here's the thing, this supply chain is unbelievably concentrated in one country, China. The source materials shows that China controls over 70% of the world's polysilicon, and then get this, an astonishing 98% of the ingots and 97% of the wafers, and over 80% of the cells. Now that kind of dominance, sure, it's efficient, it makes things cheaper, but it also creates some extreme vulnerabilities and risks. So here's the crucial point, that supply chain concentration leads us directly to a major ethical problem. Over half of China's polysilicon, the literal foundation for most solar panels in the world, comes from the Xinjiang region, a place where, as has been widely reported, forced labor systems are in effect. This whole situation brings us to a really difficult ethical crossroads. It forces us to weigh the undeniable long-term benefits of clean energy against the very real immediate harms of its production. And here is that dilemma laid bare. On one side, you've got over 25 years of clean energy from a single panel, which helps replace fossil fuels and cut global emissions. Fantastic. But on the other side, you have a high initial carbon footprint to make the thing, you've got hazardous waste polluting local communities, and you have that shadow of forced labor hanging over the whole process. And you know what? This production footprint isn't shrinking. This chart shows what's called the carbon footprint growth ratio. It's basically tracking how fast the carbon footprint of manufacturing is growing year over year. And as you can see, that growth is actually accelerating, especially in China. This means the environmental burden of making these panels is getting heavier. And that burden is being shouldered by the regions that produce them, not the ones that install them. The problem doesn't even end there. After 25 or 30 years of generating clean power, we're facing a massive disposal challenge. Turns out, solar panels are not easy to recycle. The valuable materials are all bonded together so tightly that separating them is incredibly difficult and expensive. So, we're creating this ever-growing stream of e-waste. So, where do we go from here? Well, fortunately, this isn't an unsolvable problem. There are clear strategies we can use to make the solar industry more sustainable and a lot more ethical. It really comes down to three key things. First, adopting cleaner manufacturing technologies, innovating new processes that use less energy and fewer nasty chemicals. Second, we have to build a serious recycling infrastructure from the ground up to handle all those old panels. And third, reshoring. That means moving manufacturing to places with stricter, more transparent labor and environmental laws. Let's just zoom in on that recycling piece. This diagram shows a circular economy in action. Instead of old panels ending up in a landfill, they get collected and disassembled. All the valuable materials, like the silicon, silver, and copper, are recovered, purified, and then fed right back into the system to make new products. This closes the loop, which means less waste and less need for new mining. It's a great idea. But as this slide makes pretty clear, there are no easy answers here. Cleaner tech requires a huge upfront investment. Recycling, right now it's expensive, and we just don't have the infrastructure. And reshoring, well, it would ensure ethical standards, but it would almost certainly make solar panels more expensive, and that could slow down the whole energy transition. Each path has its own set of really tough trade-offs. Ultimately, this isn't just a technical problem, It's a philosophical one. How we navigate these trade-offs really depends on our core ethical values. So, a utilitarian would look at the big picture. From that perspective, the immense, long-term benefit of fighting climate change for billions of people, well, it probably outweighs the localized harms of production if we are actively working to minimize those harms. For a utilitarian, it's all about the greatest good for the greatest number. But a deontologist, they would fundamentally disagree. They'd argue that some actions are just plain wrong, period, no matter what the outcome is. From their perspective, using forced labor or knowingly polluting a community violates a moral duty. The outcome of clean energy, no matter how good it is, just can't justify unethical means. And that leaves us with the fundamental question. We all want a sustainable future, but getting there requires us to confront these uncomfortable compromises that are embedded in our most promising technologies. So we have to ask, what is the true cost of clean energy, and what price are we as a society willing to pay?